Welcome back to the 2024 AP exam. This is question 1C. So in this question, a student is titrating sodium hydroxide into a flask of lactic acid. And the titration curve, or the graph here, shows the changes in the titration as the student is performing the experiment. So before we answer the question C, just as a reminder, a titration graph or a titration curve tracks the titration as you're doing the experiment. So for example, over here, when 0 milliliters of base were added, the pH represents the pH of the acid. I'll put a little star there. It represents the starting pH of that lactic acid, which is around 2, before you began titrating. Now, as you start titrating the base into the acid, we see that the pH is still acidic for the first little while, and you have to go back to titration lessons from class, but basically how we explain this is you have to look at what is excess. So what compound do you have more of? And if we see that the pH is still in the acidic range, the acid is excess and the base is getting consumed, okay? Now, all along in this titration, we're adding base, okay? So as we go along here, we're adding more base, and at some point, we've added 16 milliliters of base. And this 16 milliliters for this titration represents the equivalence point, okay, which I've circled there. And that equivalence point, the meaning of that is the moles of base equals the moles of acid. So at this equivalence point, there is no excess reactant. You basically just have products, which are water and the sodium lactate, which is it's actually a basic salt. That is why the pH is a little higher than 7 during equivalence point. Okay, with all that being said, to calculate or to find the pKa of the lactic acid, you guys may remember from class that the pH equals pKa at the half equivalence point. So what do I mean by half equivalence point? The half equivalence point is when half of the acid has been neutralized, okay? So half of the acid has been neutralized. And so if you think about it, that would actually occur here at 8 milliliters. So if 16 milliliters was the full equivalence point, 16 milliliters of base added, then 8 milliliters of base represents my half equivalence point, which is approximately here on the graph, which has a pH of 3.9, which will be equivalent to the pKa value of lactic acid. Remember, you could also find pKa by taking the negative log of Ka, but we don't have that information in the question, so we have to, and it says here to use the graph, so we have to use this relationship to determine the answer. Okay, now in the next question here, I'm given a little molecular model and a diagram, and I wrote the chemical equation on top just so we could visualize it again. So this molecular model shows us what's going on in the titration, and we basically have to figure out where are we in the titration and put an X on the titration curve where you think all of this occurs. So what I can see from this diagram is I have a lot of molecules, or I have more molecules of acid, of this lactic acid. And so that is my excess reactant. Okay, so I'm going to make a little note here that my lactic acid is excess. And when I mean excess, I just mean that there's more of it. So as you've titrated, I have some sodium ions, and I have some conjugate base ions, but I still have more acid than I do conjugate base. So therefore, the acid is excess, and not all of it has been neutralized. And so on my titration curve, the answer on your AP answer key indicates anywhere from 3 milliliters to 8 milliliters. So anywhere from here to right before the half equivalence point, anywhere from here to here, we can mark an X that represents our excess acid as not enough base has been added to neutralize it even to the halfway point. Okay, and I kind of explained the justification of the answer, but what we can say here is that we have more. I'll write it down here for you. So there's more. There are more acid molecules than conjugate base molecules or particles. Okay, meaning that we have excess acid and we have not yet even reached the half equivalence point. All right. I think I will do the next page in the next video, so please check it out if you are interested in question D continue.